Hi there, this is GCSE Forces lesson 15 and this is distance, speed and time, and the objective is to simply recall and then apply the distance, speed and time equation. So it should be pretty straightforward. Right then, so average speed. So the equation for average speed is distance equals speed times time. Or D equals S times T. Okay, so distance typically is measured in meters. They can be slightly different, however. Let me just attempt to put a box around this. There we go. So distance will typically be in meters. Could be in kilometers, you might have to convert it. Time would be in seconds. Speed, meters per second. So if you want to write that down, we'll do a few examples. I'll show you how to rearrange it and stuff. It should be pretty straightforward. Right, let's move on. Right, okay, let's do this one first. So if you're confident with the maths, if you want to have a go at this first, please do so, then I'll take you through the answer. If not, you can watch it as an example. So this one says calculate the average speed of a car that covers 500 meters in 20 seconds. So we've got the equation, if you remember it, it's D equals S times T, so distance is speed times time. And then you can just put your numbers in. So the distance is 500 equals speed. Now we're looking for speed, so we'll call that S times time. Time is 20 seconds. So if you're in a maths lesson, your maths teacher might ask you to find S or make S the subject. So speed, we need to get rid of the times 20. So to get rid of times 20, we take it to the other side and we do the opposite, which is divide. So it'll be 500 divided by 20, and that will give us the speed. And the speed is 25 meters per second. Let's move on to the next one. Right, if you want to have a go at this one, pause and have a go. So sound waves travel at about 340 meters per second through air. How far will the sound wave travel in 1 minute? So we need to do distance equals speed times time. So the distance is what we're looking for, equals the speed, which is simply 340, multiplied by 1 minute. Now if you multiply by 1 minute, you're going to get this wrong. So what we need to do is to convert the 1 minute into seconds, and there are 60 seconds in 1 minute. And then it's simply 340 multiplied by 60, which will give you 20,400 meters. Or 20.4 kilometers. All right, let's try another one. For this next one, we're going to need to do a speed conversion. So what we're going to do is try to convert 100 kilometers per hour into meters per second. So if you want to have a go at that, that's okay, you can pause. But I'm going to show you a technique. So 100 kilometers per hour is 100 kilometers every hour. So we can write it like that. So that's 100 kilometers per hour. And what we need to do is just convert the unit. So 100 kilometers, if you want to turn it into meters, would be 100,000, because kilometers, remember, just means, well, kilo means 1,000. And then we need to divide that by the amount of seconds in 1 hour, which is 3,600. So we times by 1,000, divide by 3,600. That should change the units into meters per second. And then you just need to do 100,000 divided by 3,600, which would give you 27.7 recurring meters per second. So essentially what we did, we times by 1,000 divided by 3,600. So that's the same as, well, if we times by 1,000 divide by 3,600, you can check that if you like, but it's the same as dividing by 3.6. So if you want a quick way, if you want to go from kilometers per hour to meters per second, just divide by 3.6. Okay, right, let's try the next one. Right, so if you want to try this one, calculate the time taken for a car travelling 120 kilometres per hour to travel 4,500 metres. Give your answer in hours and seconds, maybe hours and minutes and seconds. Let's just see what it is. So we need to convert the speed into metres per second, and then we've got our distance. So let's do the speed first. So 120 kilometres per hour is 120,000 metres divided by 3,600 seconds, or 120 and just divide by 3.6. So that would give you 33 and a third metres per second. So that's the first job done. Then let's write the equation. So distance is speed times time. Then let's put some numbers in. So the distance is 4,500 equals the speed is 33 and a third times time. So to get time on its own, the t, I need to get rid of the times 33.3. So I need to do the opposite and move it to the other side. So I need to do 4,500 divided by 33 and a third. And that'll give us the time. So if you calculate that, that gives us 135 seconds. So that's definitely not hours. That's obviously a mistake. That should be minutes. So to get into minutes, let's just, 2 minutes is 120 seconds. So you got 2 minutes and 15 seconds. Hopefully that one went okay. Right, let's finish with a table. Right, if you want to do this one, you don't have to draw the table out. You can just treat them as, 1, 2, 3, 6 questions. Stick to the units what are given. Okay. And try and complete it. And then I'll take you through the answers. So the first one. So what's average speed? So we've got a distance of 60 metres and 3 seconds. So what I'll do is this. Let's call it question 1. So you should have you working out your answers. Let's go through them. So distance is speed times time. Distance was 60 metres equals speed, which we're looking for, times 3. So speed would be 60 divided by 3, which is obviously 20 metres per second. So look at number 2. So the second one, distance is speed times time. And you'll notice that in my working out, I've got the equation, the working out, the answer, and a unit every time. That's just good practice. It's good for examinations. If I do the working out but may do a calculator error, I can still pick up marks in a question. So it's a good thing to do, rather than just do it on your calculator and put the answer in. That's probably not, it's definitely not a good thing to do. So the second one, distance is speed times time. So it's 40 metres per second multiplied by 35 seconds. So that gives us a distance of 1,400 metres, or 1.4 kilometres. So number 3. So number 3 wanted the time. So that's distance is speed times time. So the distance is 300 metres equals the speed, which is 1,500, multiplied by time. So we need to get time on its own, so we need to get rid of the times 1,500, so we need to do the opposite of times in by that. So that would be 300 divided by 1,500 to give us the time. And the time on question 3 is 0.2 seconds. All right, and then we've got 3 more to do. So question 4 gave us a distance of 80 kilometres and a time of 2 hours, but wanted an answer in kilometres per hour. So we can just write distance is speed times time. So the distance was 80 kilometres equals the speed, which is what we're looking for, times the time of 2 hours. So I need to get rid of the times 2 hours, so I need to divide by 2 hours, so it'd be 80 kilometres and divided by 2 hours. So as you can see, the units are correct, kilometres per hour. So 80 divided by 2 is 40, and the units kilometres per hour. Right, the next one is probably the trickiest one. So number 5. By trickiest, I mean most fun. So distance is speed times time. However, this time it's in standard form. If you haven't done standard form yet in maths, then don't worry, you might want to come back to this at a later date. But I'll try my best to explain it. So it's 150 times 10 to the 6. Now, times 10 to the 6 just means 6 zeros, so that's 150 million. But then there's a kilometre as well. So what you would have to do, you would have to do 150 times 10 to the power of 6 in your calculator. And to do that, I'll do the buttons. So you would press 150, 150. And then the times 10 to the power button is normally at the bottom. So on a Casio calculator, it's at the bottom and there's a button and it says times 10 to the power of x. So you would say that 150 times 10 to the power of, and then you just press 6. So that's how you key that in. And then it's kilometres, so what you actually need to do is multiply that by 1,000, because obviously kilo means 1,000, so you've got 150 times 10 to the 6 times 1,000. Now your calculator will do that for you. It'll give you a distance of 1.5 times 10 to the 11. Which you don't have to convert, it's fine. That's in metres now. So let's go back to the sum. So distance, we just calculated 1.5 times 10 to the power of 11 equals the speed 3 times 10 to the power of 8, which again you would put into your calculator as 3, that button, times 10 to the power of, and then just 8. Multiplied by time. So to get time on its own, we need to divide by 3 times 10 to the power of 8, so it's 1.5 times 10 to the power of 11, divided by 3 times 10 to the power of 8, equals the time. Now the time is 500 seconds. So if we divide that by the amount of seconds in a minute, so it'd be 500 divided by 60, you will get 8.3 recurring, so that's 8 1/3 of a minute. So 8 minutes, and then 1/3 of a minute, so if you do 60 seconds times 1/3, or divided by 3, you get 8 minutes and 20 seconds. And it's an interesting one, that, because the 1.5 times 10 to the 11 is the distance from, the average distance from the Earth to the Sun. The 3 times 10 to the 8 meters per second is the speed of light, and the time that we've calculated is the amount of time it takes light to travel from the Sun to the Earth. Let's finish one more then. So number 6, which is actually a lot easier than number 5 in this instance. So number 6 is, so distance is speed times time yet again. So distance is a kilometre, which is, a kilometre is 1,000 metres, equals the speed, which is 330 metres per second, times the time taken. So we need to get t on its own, make it the subject, get rid of a times 330, so it'd just be 1,000 divided by 330, which will give us the time. And 1,000 divided by 330 is 3.03 seconds. If you just put 3 seconds, that's fine. Hopefully you found that okay. Maybe a bit challenging towards the end, but I hope you found it useful. Thanks for watching, and I'll see you at the next one.